Hey there everyone, all the techies and data enthusiasts there. So guys, welcome back to my YouTube channel. This is video 6 of our Python series, and in this particular video, we are going to discuss about operations and methods of data types. So in this particular video, we are going to deep dive into different types of operations which you can perform and what all are their data types, and also we'll be practically executing them in this particular video. So guys, this video is definitely going to be very interesting. If you have not subscribed the channel, do subscribe the channel and on the bell notification. Also share this video with your friends who want to learn Python. So it will be very helpful for the community and even they can learn Python very easily. So guys, now let's not waste our time. Let's dive into my computer screen. So guys, today we are going to discuss about operators and methods of data types. Data types in Python, we already discussed in our previous video where we have discussed about variables and data types in Python. So we have three data types if you remember, that is int, float, and even character you have, and boolean also. So the fourth data type is character, which is nothing but strings. So but in this particular video, we are going to deal with some of the operations which you are going to perform with this particular data types. Number one is integer data type. So integer data types are nothing but your whole numbers, or you can say 1, 2, 3, 4, 5, 6, these numbers. So in previous video, I have explained them very clearly. If you have not watched that particular video, that is Python series video 5, check out that video very fast. The link will be in the iCut session. So now let's go further. So in this particular video, we are going to perform arithmetic operations for integer data type. So you have addition, subtraction, multiplication, division, floor division, modulus, and exponential. So these are the different data types which you have, or you can say data type of arithmetic operations which you have, you can perform. So let me just copy all of them. So you all have the results here, but I'll run and show them here. Okay. So I'll explain one by one now, so you don't feel it difficult. That's the reason I'm mainly taking the same examples. I'm not going to change any examples. If I change, you might feel confused. So which is in the book, the same examples we are going to take. If you want that particular book, you can check out the link below. There is a GitHub link which I have attached, in which all the code I am writing and even the PDF notes of the book which I have written, Python Simplified, in which everything is written in a simplified version to easily understand. You can download that. The same book I am using to explain you all. Okay, so this has been run successfully, but yeah, so there is, okay, there is an indentation error actually. Let me just solve the indentation error. Now let me run this. Yeah, it works. Okay, so now I can check addition. So what is my addition? 10 plus 3, which is nothing but 13. So you can even verify that. I hope you guys definitely know the maths. I'm not going to verify this. So addition, subtraction, and multiplication, everyone knows, okay? And even division as well, I guess everyone knows about it. So I'm not going to specifically explain about this particular calculations. So what is floor division? So many of them might have the question, what is floor division? Floor division is nothing but it is going to round off the division value or division output value, you can say. For example, you can see a 10 by 3. So after division, you get 3.333 something. Okay, when it comes to floor division, it round offs the value and it prints you as 3. So if you don't want a float value or a decimal point, you can go with a floor division where if the particular value is above 3.5, for suppose if here you have 3.333, so you got the round off value of 3. If it was above 3.5, it was 3.6 or 7, then your round off would be 4. Because if it is above 0.5, it will consider the next round of value. If it is less than 0.5, it will consider the previous round of value. Okay. Don't confuse here. Modulus. Modulus is nothing but x percentile y, which is nothing but if you want to work on some percentage, this will be very helpful. So you can check here 10 percentile 3 1. So I verified it here. Okay. And exponential. So what is exponential? Exponential is nothing but a particular value like x divided by 3 times of the y value. In short, so your x is nothing but 10 divided by 3. So you have given 3 times. So exponential in essence 3. So the 3 in essence it is going to cube it. So 10 into 10 into 10. So 3 times it is going to work on that. Then you get 1000. Okay, I hope you all are getting this. Let me just zoom in this a bit so that you all can view this properly. Yeah. Okay. Now let's move further. Comparison operator. So what is comparison operator? To compare whether a particular value in x and y is absolutely perfect or the condition is satisfied or not. So you have different comparison operators, that is equal to, not equal to, greater than or equal to, less than or equal to, greater than or equal to, sorry, this is greater than and less than, greater than or equal to, less than or equal to. You have all these operators. Okay, so let me copy the same example. Here you have 10 divided by 5. So previously we were having 10 divided by 3. Now we have 10 divided by 5. So again the same indentation error. So this outputs, let me remove the output so it's easy to explain you guys. So let me run this. Now x is 10 and y is your 5. Remember this. So is x equal to y? So if you print this, you get false because it is you can say not equal, right? So 10 double equal to 10, then it will be equal. So condition satisfies. So if your y was also 10, then it would be printing true, or else it used to print false. So when it comes to, let me just change and show it you 10. So let me run this again. So you can see now the condition satisfied true. Okay. So let me keep this the same. So equal to condition is false. Is equal to. Is not equal to. So what is not equal to? Means x condition is not equal to y. In a sense, in x you have a value of 10 and in y you have a value of 5. So it's not equal, right? Obviously, the both are not equal. So the condition satisfies, and when you run this, you get the output as true. Okay. Is x greater than y? Obviously, right? 10 is greater than y, or you can say 10 is greater than 5. So this condition obviously satisfies, so it is true. Is less than, so is that particular condition less than, or you can say 10 less than 5? Obviously no, right? So the condition will be false. Is greater than or equal to, so is greater than or equal to, so 10 is greater than or equal to 5. True, right? So obviously the condition is true. 10 is obviously greater than 5. So is less than or equal to, false. So now here, if I change this to again 10 and if I run, so what will be my greater than or equal to condition and less than or equal to condition? I can say both of them will be true because both the side less than or equal to, you are defining either that particular condition should be, or that particular value will be less than, or it should be equal to the same of the x. So the condition, one condition is satisfying, right? Any one condition, if it satisfies, it will print true. Okay. So I hope you all got this comparison operator. Methods and abs. Okay. So Python has built-in methods and attributes. This allows you to perform various operations and access information about integer objects. Some common methods and attributes include abs, that is nothing but absolute value of an integer, and bit length, which is nothing but returns the number of bit necessary to represent a particular integer. To byte, convert the integer to byte. Create an integer from a byte string. So it create from byte will do, it will create an integer from byte string. Real, the real part of the complex number. So it will print a complex number, which is combination of both string and integer, you can say. So let us take the same example here, which you have. I'll copy this. So for now, let us only print x, absolute y, and things. After this, you have float division. Okay, let me remove this hashtag here. So I'll run this. What will be my absolute value? So I can print here absolute. 10. What will be my bit length? Is 4. In short, it's nothing, absolute is nothing, but it is not going to consider whether that particular value is positive or negative. So whichever value it is, if you even define negative of 100 also, it will give you an absolute value that is 100. No positive or negative signs are there in absolute. Bit length. So it converts the 10 minus 10 value to a bit and it represents here that is 4. Okay. So left out things will be working going forward on it. So now if you I try to explain you all, you will feel it very complex, especially the real or a complex number. Float data types. So again in float data types you have the same modulo, exponential and everything. So all those things which I have explained previously, the same things for float data type. Okay. So let me mention that here. So I'm not going to specifically explain all of them again for you all. So I'll just run and I'll show you all practically, but theoretically I'm not going to explain. Let me first define here at the up here markdown, and I'll define this for integer data type. Okay, this is for integer data type. And now we are going to discuss for float data type. So for float data type, you have the same values. So let me just run them. Float are nothing but your decimal values. In short, 3.5, 2.0, which we have defined here. You all can see here. So addition of it, what will be the value of 3.5 and 2? It will be 5.5. Subtraction. So if you multiply, you should, minus, you should get 1.5. So multiplication, the same goes for multiplication, 7. So 3.5 and 2, 15, and yeah, that's all. 7. 7.0. Division 1.75. So you can just divide and see if you want. You can practically even in Python, what is the advantages? You don't have any syntaxes, right? You can practically try it. For example, here you have 3.5 and 2.2, right? 2.0. 3.5 into 2.0. So you can practically run here and see you got the output 7. So condition obviously valid, right? So Python's inbuilt multiplication function, you can say it's working, right? Now for the division, same goes for division. So for division also same, you can say 3.5 divided by, oh, it's floor division, right? 3.5 divided by 2.0 and you can run it. So you can see here. Same goes for floor division. So when it goes to floor division, okay, you cannot perform floor division for your, you can say float data type. Remember this, okay? It will throw you an error. When it comes to modulo, so same goes for modulo as well. 1.5 and exponential. So exponential, what it will print, let us see. 12.25. Sorry, 12.25. Yeah. So now let us see how it works. So the same it goes for 3.5, right? 3.5 into 3.5. So what will be your output? It's 12.5. Yeah, obviously 2 times only it's going to perform, right? Because we have defined here 2.0, which is nothing but 2. So we are just telling the model, or else you can say the exponential model, how it's working, right? It is telling. So in your A, you have 3.5 the value, multiply it 2 times. So 3.5 into 3.5. So you got your output here. So if you mention here 3, immediately the output will change. Oh, sorry, not here. Yeah, here. 3.5 into 3.5 into 3.5 again. If you mention 3 at there, you have to run 3 times. So you get it 42.875 for 3 times if you multiply. But we mentioned only 2, right? So this is enough for us to verify. Comparison operator. Again, you have a comparison operator, but here there are some different comparison operators. but they are same as your, you can say, integer itself. So comparison operators are same as your integer operators. You can try out the same here also. Let me just copy them here. So I have specifically not written there because it is same. There is no changes at all. So let me copy this here and I'll just show two examples for you all for comparison operator. You will immediately get it. Okay. Comparison operator. So here I can mention the same of 3.5 and here this can be 2.0 and I can print all of them. Okay, so I have to print all of this again. Let me just run it. Let us again print them. It's not a big deal. Copy this, run here. You can see here it's false. So obviously is equal to, it's not equal to, right? So it's false. Is not equal to, it's true. The same, there are no big changes. So I guess you all got it. Same for goes for greater than or equal to. Is x greater than y? So obviously yes, it's true. Is x less than or equal to y? So it's not even equal also, and it's you can say its condition is failed, right? So obviously x is more than y, so false. Okay, so there are different methods and attributes which you need to know. Is integer, so returns true if the float is an integer, otherwise returns false. So there is an inbuilt function called is integer which will return true if that particular float value which you have entered is an integer or else it is false. Hex returns whether it is an hexadecimal or not. It's an hexadecimal representation or not. And integer ratio returns a tuple containing the numerator and denominator of floats exact values. And integer ratio, this will return the numerator and denominator of that particular value. So here you have an examples of it, or you can say example code. Okay, indentation error. So is integer. So in is integer we have stored a variable. So it's false. Obviously that is not an integer, right? So it's an decimal point. So now if I run this, okay, an int object has no attribute is integer. Okay, so this is only for float. Got it. Okay, okay. So it will just check whether that particular value is integer or not. Okay. And hexadecimal representation. So what is the hexadecimal representation of 3.5? This is your hexadecimal representation of your 3.5. Okay. And numerator and denominator. So you can just copy this and we have to use your print statement. Print numerator and denominator. You can see here 7 and 2. These are the numerators and denominators of 3.5. Okay. It's very easy to find out them. String data types. So after string data types, so yeah, string data types, you have many things to explain. So I hope string data type, let's make a separate video. For this particular video, it's enough. If you understand the integer data type and its operations, float data type and its operations, it's enough. So I don't want to make the video more lengthy. So guys, that's all for today's video. Do like, share and subscribe the channel. And also make sure to comment below if you have any doubts. I'll definitely reply for your comments. So guys, meet you all on the video 7. Bye bye.